Just a quick question. Is there like I don't know, is there like a number of buttons that you can give an optimizer past which it's not very useful? I'm just thinking about like that trajectory optimization Troy and I were working on with the Fourier sine series.
Mhm.
And increasing the number of coefficients, you increase the number of buttons you're handing to this optimizer. Um, do you have any tips or tricks about playing with those type of things, I guess?
Oh, that's a good question. So typically the way I handle it, and I'm not saying that this is the right way, but
Mhm.
what I've tried to do in the past is I gradually add more knobs that it can turn, right? So I would say optimize. Let's say I'm only going to give you 3 or 4 to start with,
Mhm.
or maybe even just 2. Because I can visualize that design space. Maybe I'll just give it 2 to start with, and I have it find an optimum within that two-dimensional design space, right? And then I use the result from that as the initial guess for the first 2, and I then give it 4, right? But I have an initial guess for
Gotcha.
the first 2 because I know how those 2 are kind of related. At least if the rest were set to 0, I know how they're related. Does that make sense?
Mhm. Yeah, yeah.
And then I give it 4, and then I find the optimum, and then now it has a solution for 4, and then I add 2 more or whatever, and I just keep adding. So I kind of do this hierarchy of optimizations where I give it more and more design variables to work with, but I'm using initial guesses for most of them that came from previous optimizations that were building up to it. you know
Gotcha.
Now,
Okay.
I don't know if that's the right way to handle it. I think it completely depends on what the design space looks like. And
Mhm.
they can get very complex with when you have many variables. It's harder to visualize. And again, you can take two-dimensional slices, through higher dimensions or whatnot. But it's hard to get a feel for what the whole n-dimensional space looks like and whether or not gradient base is going to get you to the global optimum within there.
Gotcha. Gotcha.
So
Okay.
generally, I would say genetic algorithms are better for high dimensional spaces.
Mhm.
The way that they search, the number of calls it takes to solve it, I think that they're just more efficient and better at really high dimensional spaces. But if the space again is really well behaved, if the gradients are nice, if there's only one global minimum, then gradient based algorithms should do really just fine and actually outperform genetic algorithms,
Gotcha.
even in higher dimensions, I believe. So
Okay.
yeah,
Cool. Thank you.
I don't know if that's very helpful, but that's
It is.
just shooting from the hoop or hip from my experience. So